Welcome to the project demonstration of automated dual axis sun tracking system for optimal solar energy capture. So the main application of this project is we are going to rotate this solar panel toward the sun. Whenever the sun is moving from east to west, then these two LEDs will identify the sun position, and it always places the solar panel perpendicular to the sunlight. Means when the sunlight is falling on the solar panel, that should be perpendicular, and that will be detected by these two LER sensors. And when the sun is moving from east to west, then this servo motor will rotate this solar panel to the east to west. So it's the west side and the east side, as well as remaining two LERs are used to detect the sun position whenever the sun deviated toward the south side due to this winter season. In the winter, the sun is deviated toward the south side from the north deviation. That will be detected by these two LER sensors, and this below servo motor will always try to place the solar panel always towards the sun in terms of like during this winter season, and that will be controlled through this Arduino Uno board, and also we are using the RTC, that is a real-time clock. The purpose of this real-time clock is whenever the cloudy in the scenario, then these LERs can't detect the sun position. Then this LER, this RTC will provide the timing to this Arduino Uno board, and based on the timing signal, based on the time, the servo motors will be placed in respected sun position. For example, in morning 8 o'clock, the sun is going to be around of 30 degrees, and then if LERs are not providing the inputs when due to the cloudy some other scenarios, then the servo motors will be kept exactly 30 degrees with the help of this RTC clock. As the microcontroller, this Arduino Uno board continuously read the clock and LER sensor. Whenever this LER sensor is unable to provide the input, then only it will take the input from this real-time clock and control the servo motors. So the main input modules in our project is 4 LER sensors to get the sun position exactly, and the RTC clock to check the timing whenever the LER is not providing the proper signal to this one. And this LED indication will just show the availability of power from this solar panel here, and the total system getting power supply from this adapter, which will take 230 volts or 110 volts DC inputs, and will be provided the 5 volts of DC output, and that is the main operating voltage of our system, that is our servo motors as well as our nano board. So let us check with the demonstration. Right, so just when we on this power supply, then these servo motors will be kept initial position, that is based on this RTC clock, as there is no proper lighting signal to this LERs. And whenever the light detected, as you can see that slowly it will be controlled, and we can observe the light intensity is increasing from this LED indication, which is showing the status of the availability of power. Slowly it will be controlled. And whenever the sunlight is not available, then automatically it will kept to the normal position as timing signal. Means based on the RTC clock input, it will be controlled. So the main application is to get the maximum power due to this like sun traveling from east to west. Then the system try to place the solar panel always facing towards the sun to get the maximum sunlight, so that will get the maximum power. And when all these will be covered, means there is no like signal from the LDR, then the system will control the servo motors based on this real-time clock input. Again, you can see this. When the lighting is more, then the light will be indicated, and low lighting, no lighting. Right. Thank you.